Test. Right. Let's start today's lecture. So last week we finished talking about BDD or behavior-driven design. It's basically a combination of a technique which is user story to help define, to help communicate with non-tech people to define the behaviors that's desired for an application. And some tools to track the progress, manage your tasks, hopefully get better estimates, and also a tool which is Cucumber to translate the user stories into real testable code. So that was about BDD, but instead of focusing more on testing, we actually focus more on the planning phase of a project, or the figure out the requirements, the desired behavior, the specifications, and then more on the project management side, where we introduced the pivotal tracker to track to monitor the project. So starting today, so for this week, we're going to talk about TDD, which is test-driven development. So for this week, we'll focus more on testing, or more specifically unit testing, although we will talk about different types of testing. But TDD in general, or test-driven development in general, is a way to actually doing development. So compared to TDD, so as an opposite of TDD, we'll probably think about something like imperative development, meaning you gotta assign a task, you figure out what to be implemented, and then you start writing the code that actually implements the functionality. So some would call it imperative because it's imperative, and then TDD is kind of a reverse way to do that, where you write the test first and then you start the implementation. But yeah, the videos, we will watch the videos which will explain more details. And again, TDD is part of the agile practice, or more like extreme programming practice, where many people adopt that, but also you definitely can see projects, especially smaller scale projects, don't really do that, but we will discuss about that later. Okay, so without further ado, we will get to our first intro video for TDD.
A previous module introduced behavior-driven development, in which user stories in plain English, combined with low-fidelity user interface mockups, could be turned into high-level Cucumber scenarios that serve as both integration tests and user acceptance tests. Scenarios are great because they exercise your whole app, and they stimulate it in the same ways that real users would. That makes them pretty realistic as test cases, but they're not very thorough. The simple scenario we introduced in the previous module's intro video, in which a user added a new movie to Rotten Potatoes, is what we call the happy path. It describes what happens when the app is working correctly and the user does everything exactly as we expect. But we all know that in real life, all kinds of things can go wrong, whether because of bugs or because the user behaves differently than we expect. Even in the simple example of adding a movie to Rotten Potatoes, what would happen if the user left some required fields blank when submitting movie details? or if they tried to create a movie that already existed in the database. Surely, we don't need to create a full scenario for every different SAD path, do we? And even if we did, how would we know if we had covered all the cases? In this module, we'll take a deeper dive into testing by creating unit tests, which test a single method in a single class, and module tests, which test a behavior that involves several methods, possibly in multiple classes, but still smaller in scope than a complete trip through the app like a scenario. We'll use RSpec, which you've already seen in passing in some of the programming assignments, to create these tests. Unit and module tests are complementary to scenarios in that you can't rely on just one type of test. As we'll see, unit tests can run very quickly and can explore code paths that are awkward to reach with scenarios, but they artificially isolate the components under test from the rest of the system, so they don't really test the interfaces or connections between components. In contrast, scenarios exercise code across module and class boundaries, but they're much more heavyweight, so they run more slowly, and they cannot always illuminate the dark corners of your code like unit tests can. Similar to how you can write scenarios before your code is written, the practice of test-driven development, or TDD, advocates writing unit tests before you write the code so that the test will drive the development of the code just as with BDD. As we'll see throughout the rest of the course, a less obvious but critically important benefit of test-driven development is that writing tests makes you think about how the code you're about to write will be called, and that leads to better structured code. In other words, testable code tends to be good because good code is readily testable. Because unit and module tests are intended to test a method or a small set of methods in isolation, you'll learn how to create and use test doubles to decouple the behavior of the methods being tested from the behavior of other methods they may depend on. You'll also learn that determining how much of your app is covered by tests is trickier than it might seem. So, like all other metrics, you'll learn to measure different kinds of test coverage, but take the numbers with a grain of salt and with good engineering judgment. Getting good coverage with a combination of scenarios, unit tests, and module tests will give you confidence not only that your app will behave correctly when users don't behave as you expect, but also that as you evolve and change your app in the future, you'll know immediately if you broke anything because one of your tests will fail. This safety blanket will be especially useful when modifying code you didn't write, as we'll explore later in the module on legacy code.
All right, so that's a quick intro about TDD. Do you want to highlight some parts, especially the last part that the professor talked about, the benefits we will gain from TDD. In my opinion, the major benefits we get from TDD would be for maintainability, either for yourself or someone else down the line to make modifications to the project, to the application. With tests in place, it's rather easy to identify if the latest changes break anything. Where otherwise without tests, it's very common that a change or modification would affect something else in the application and hence break the system. And then there's some other minor benefits that I don't think the professor mentioned. One is sometimes with tests in place, you may not need to write as comprehensive documents as in projects that you don't have tests. Because with tests, often the test itself tests also include what we talked about last week. That's from BDD. So behavior-driven design, the cucumber test is also a form of test. Anyway, with tests in place, sometimes instead of writing documents to show examples or use cases, you could actually direct developers to the actual test case to see the example codes. And then actually many times I did that, especially for open source stuff like plugins, for those that's gems or some packages. Sometimes it may not be well documented, especially for some corner cases, like for a very specific argument, like if I assign true or false or a different variable to an argument, how it would change the behavior of the plugin or the package. Sometimes it's really difficult to convey all the details in documentation. Then in that case, if you have tests in place, whoever is using that, whoever cannot find enough information in the documentation, they could actually go through the test to find more details. And then there are a couple other benefits for implementing tests, and then there are other ways to do tests, right? Here we talk about TDD, where we write the test code first. But the other way around is you can write the implementation first, then test it after that. So that's also another way, and then you can do that. That's also beneficial. And then some of the benefits that comes with TDD, it can also be applicable even if you write tests after the implementation. But we'll talk about the other benefits later in today's lecture. So for now, let's just continue to the next slide.
How do these tests sort of relate to each other? This is what we call the sort of inside out or outside in, which I guess is the same thing. The cycle of behavior-driven and test-driven development. The outer parts are the parts that you already sort of have seen how you do them. You can write a cucumber step and the appropriate step definitions that would support it. And the idea is that you're writing these before you're writing the actual code. Right? So obviously the step will fail because there's no code to implement it. So now the next task is, OK, let's go write the code to make that step pass. But the way that we're going to write that code is we're sort of recursively going to do this. We're going to look at what are the specific behaviors that code has to have. And for each one of those behaviors, we're going to look at writing either a unit or functional test as appropriate. Initially, that unit or functional test will fail because we have no code. Then we will kind of backfill the code to make just that one pass. And eventually, we're going to get to where all of the behaviors assumed by the cucumber step, by that particular cucumber step, are now implemented in the code, and they have tests to cover them. At that point, you have a collection of RSpec tests and code that collectively implement whatever that step def needed, and that makes the step def now pass. Right? So in the pure version of BDD plus TDD, this is the cycle you follow. You always start with a cucumber step. It probably fails because it's testing something new that you haven't written. And the way that you develop that new code is by doing it test first. But these tests are going to be at the level of unit or functional rather than being integration level. Right? So that's kind of generally where we're going. So what does this inner loop sort of look like? It's actually not too different from the way you think about BDD with Cucumber, but it's in microcosm. So now you're actually going to write some code. And you think about one behavior, one thing the code should do. You capture that thought in a very small test, because each test is only going to test one small behavior, as we'll see. The test fails because you haven't written the code. So now you write the code. And in fact, you write the simplest possible code that lets just that test pass. This is actually a pretty key part of TDD that is easy to overlook, trying to handle like all of the general cases immediately. Right? The sort of TDD methodology is let's get the simple stuff to work first. And then as we evolve the code later, we can add more complexity because we know that we can fall back on our existing tests to make sure we didn't break anything that used to work. Once you've gotten the test to pass, there's a step where you can see whether there's common code that is shared by many tests. You can factor it out, so things are a little bit leaner. And then you continue with the next behavior. So if you sort of Google the term red-green refactor, it refers to this. You start with tests that are failing because you haven't written the code. You write just enough code to make them pass. You do some cleanup on the code that is now working and the tests which are now working, and you repeat, right? And the idea is that if you do this in small steps, you will always have working code. For our purposes, working code means code that passes all of the tests you have. So think about it as, your code is stable. It passes all your tests. You're a happy camper. You add a new test because you need to write some new code, and that test fails. Your goal is how quickly can you get back from red, which is not everything works, to green, where everything works again, and you have like an incremental amount of new code. You take really small steps. The other advantage of taking really small steps, of course, is that if in the process of doing this, you manage to break some other test, the amount that you changed isn't very much, right? So if you're only sort of writing 3 or 4 new lines of code for this test, and you broke something, you know that whatever you broke must have something to do with the 3 or 4 lines you just added. So going from stable code to stable code in small steps is sort of the key to the approach. So let's start with a little philosophy about tests. There's acronyms for everything, obviously, in the Agile world. So there's acronyms for tests. And the acronym for what makes a good set of tests is FIRST, which is fast, independent, repeatable, self-checking, and timely. So what do each of these things mean? Fast means fast. It shouldn't take long to run them, or at least to run a subset of them, because if you're really going back and forth between write a test, write a little bit of code to make it pass, write another test, write a little bit of code to make that one pass, running tests happens all the time, so it needs to be pretty fast, right? In fact, ideally, it's automatic, where like every time you change a file, some tests related to that file get run automatically. You don't even have to do it. Independent, this one is pretty critical. The tests don't depend on each other. And that's so that you can run any subset of them in any order. When we talked a little bit about cucumber scenarios in the last week, this came up as a question of, well, if you have a cucumber scenario that puts some things in the database as part of its test, doesn't that affect the tests that come after it? Because before the database was empty and now it's not empty. And my answer was, that's correct. And that's the reason that the testing framework basically incinerates the database after every single test case. So the idea is every test should be able to be run at any time in any order. And whatever assumptions the test thinks it has to make about preconditions, that should be explicit and part of the test itself. So that's the independent part. Repeatable. It'd be nice if the test did the same thing every time. So dealing with things like the time of day in the previous example would be a challenge for repeatability. You don't want a test that only behaves properly on the 3rd Monday in August or something like that. Self-checking. This is probably, when students who don't have a lot of experience with testing, this is probably the one that is the biggest difference, which is the test automatically knows if it passed or not. There's no concept of a human being manually looking at the test output or manually checking the test results. The test does whatever it needs to do to confirm whether the right thing happened or not. So the test can self-report whether it failed. And timely just means that you write the test at about the same time that the code is written. And in fact, we're going to advocate, like I said, with test-driven development, that you write the test first, and then you write the code that passes it. OK, so let's walk through an example that handles the case we've sort of been talking about, which is how do you break the dependency between the piece of code you're trying to test and the other external things that it depends on that either you don't control or are not part of your test. So in the very first example, the external dependency was on the date. You don't want the test to really depend on the value of today's date. So in general, we're going to walk through an example going back to our friend, the Rotten Potatoes app. And here's the hypothetical scenario that we're going to walk through. We're going to want to add a feature to the app so that the user can look up a new movie by getting that information out of the movie database, the TMDB, which is the API that we played around with back when we talked about APIs in week number 2. So that means that now there's going to be some part of the Rotten Potatoes code that has an external dependency on this other service, the TMDB service. And how does that complicate the way that we do the testing? So let's make the example concrete. And by the way, if you have the book or have access to the book, there's a very detailed walkthrough of this with code examples and things you can run and stuff like that. I'm going to sort of, as usual, give you the roadmap and try to make sure that the concepts are clear. So let's imagine that you're going to use that red, red, green, green. You're going to start with a cucumber scenario that tests the feature of if I enter some search terms, then Rotten Potatoes will actually use the TMDB movie database to search for that movie. So you can imagine you're writing your cucumber scenario. You know, when I fill in search terms with the name of a movie, well, this should probably pass because Rotten Potatoes already has a page where you can enter a search key. And I press the search TMDB button. So there's some form that's going to have a button on it. And this is the step that's going to fail because we don't yet have any code that actually implements this in the app. So now the red-green refactor cycle says, OK, at this point, I'm going to pause. And to make this step turn green, I'm going to add the code to my Rotten Potatoes app that would make this actually search the movie database. Or for testing purposes, pretend we're searching it. OK, so how are we going to do that? So we're going to add our new route. We're going to have a new controller method that is going to be the controller method that receives that form submission. Right? So when you click the button, you have to have some controller method that is actually going to get control. And the question is, what does it mean to test that controller method? What is that controller method's job from the testing point of view? OK, so that's our framing. So what does the controller method do? The controller method just got handed a form with the title of a movie that the user wants to search for. And they want to search this remote database, TMDB. So presumably, one of the things the controller method is going to have to do is it will call a method somewhere that will do that search. Why would the controller itself not be doing that search, by the way? Why am I assuming right from the starting gate that the controller method is going to call some other method to do that work? In terms of model view controller. Anybody? Back? No? What's the controller's sort of purpose in life in a model view controller situation? What does the controller generally do versus what do models and views generally do? Yeah?
Set up some stuff to render a view?
Yeah, so the controller doesn't actually do much, right? It receives information from the user, and it eventually sets up things for rendering a view. But the real work, the stuff that's done in between, usually is in the domain of the model. So by saying that the controller won't actually do the search itself, but instead is going to call some other method, all I'm doing is basically reminding everybody that in a model view controller app, the controller doesn't do very much. So we're going to assume that it's the model's job to do that. And we can say that if we get a match, then we'll find a way to display it and so forth. But let's just focus on this first step. It'll call a method that searches TMDB for that movie. And you can imagine starting out the skeleton of your RSpec test with something like this. Right? We can have like a group of 3 related examples that are all connected to what happens when the user submits this search form. And the first example is going to say it calls a model method, because models do all the real work. It calls a model method that performs the TMDB search.
OK, so that's the second video. And then the following videos, we will get to more of the flash of the actual tools, which is our RSpec, and then see how TDD are implemented usually. Before we get to that, I do want to start a discussion, or start a thinking process of what are the trade-offs here by actually practicing TDD. So again, which I've already mentioned, if we the opposite of TDD is imperative, which is basically no testing, nothing at all. But actually, even you don't write any test code, most likely you still have some form of test. I don't think anyone here would just write a code and then without even try it or run it and consider the code is done, right? Always, like for a website, usually if you write some code and then most likely you are going to like open the browser and go to that page, whatever page you're working on, and refresh it a couple times to see it's actually behaving correctly. So that in itself is also a form of test. It's just that it's not automated test, where basically you cannot repeat again, and then it'll be tricky to tell someone else to test it unless you have some form of documentation that explicitly say what you're supposed to do in order to land on this page and what you're supposed to see. But regardless, even if you write code or you do your development in a imperative way, there's still some form of tests going on usually. So that's that, and then there's the test after effect, or usually people would call it QA, where the tests are implemented after development, and then there's TDD, where tests is done before development. So then first trade-off is basically writing tests versus not writing tests. So as we mentioned, the main benefits for having tests are tests would allow you in long term, it would allow you to easily spot bugs, breaking changes, stuff like that. And also for short term, if it's a big enough team, it allows teamwork where it can tell if my change would break some code that's written by someone else. But the trade-off is by writing tests versus no tests. It's definitely some overhead. You most likely need to spend extra time to implement the tests. So that's one of the trade-offs. And then if we compare TDD versus a QA process, so test first or test later. The trade-off between these two are if you test later, more typically it will have companies that runs that way will have a QA team separately. So people can be more specialized in testing, because definitely for developers, especially for beginners, it's probably going to be hard to get familiar with all the tools already, not to say that they also need to learn the testing tools, but also the thinking process. Usually people who are in QA, they think kind of differently, right? They all think about set paths, or they think about how users can use the application in a weird way, by inputting weird inputs, weird numbers, weird texts, also clicking buttons, weird ways. Whereas, especially for beginners, sometimes it's difficult to think about all these different edge cases that could break the application. So similar to like DevOps, I think in the first week we talked about that. DevOps is great, but it's some overhead, and then it also requires the person to learn both skills in order to make it happen, but sometimes it may not be possible for people that's not as skilled. So there's also trade-offs there. Do we test first or do we test later? And then the other thing is, if we test later, there's always the chance that if the timeline gets really tense, maybe you don't have enough time to test everything, but you still have to launch the application. Then if we test later, we could always just skip the test if time is really tight. But if we do TDD, we test first, then there's not, room to adjust. But again, that's trade-off. The good thing for TDD is that because you test first, it kind of helps you to wrap your heads around the actual behavior you're looking at, you're trying to implement. But also on the other side, sometimes you don't actually know exactly the desired behavior until you actually implement it. So for example, I was involved in a Chef project. If some of you may not know Chef, it's a configuration management tool plus server automation tool. So sometimes, just use that example, like some of the server configurations, the middlewares, I may not even familiar with that. I may need to learn as I go. Then in that case, it's not really possible to write tests first because I don't even know the desired configuration or the desired behavior of certain components that will be managed by the Chef code. So again, when you try to approach your project or your task, although here what we teach is the best practice is TDD, but again, there are trade-offs there, and depending on your situation, depending on your skill level, depending on your experience with certain stuff, like you may want to do it in a different way. And also, in my opinion, when a project is experimental, meaning there's no guarantee it will be a long-term project, because the biggest benefit we get from testing is to gain long-term maintainability of the code base, right? But then if the project itself is not going to live that long, then what's the point of going through all those overhead to gain that maintainability? Although some may argue that, hey, we never know, maybe a project will become very successful, and then it will keep running for 10 years or more. Yes, that's a good argument. So again, that's something you think about when you plan or trying to figure out what process you want to follow. And also the way to counter that argument would be we could always write the tests after that happens, right? Like during the experimental phase, we may just skip the tests, but then somehow later a project or application become popular, become successful, and then we could start writing tests. Although usually there's a pain, it's a painful process to write tests if it's not already in place. But that's also an option out there. And then the other trade-off, as I mentioned, it's overhead to trade for a product to be manageable for a big team. So again, if a project is more or less experimental, plus it's just a small team, or more commonly it's just going to be a one-man team working on a project, then in my opinion you're better off just skip the test, whatever. And then if it's really necessary, you could always revisit that later. But again, that's my opinion, and then there are different pros and cons by choosing a different approach. Okay, so that's enough thinking process for TDD, and then in your projects again, think twice before you decide how you're going to approach that. But also, if it's your first time, I also encourage you to try it anyways, and then just to feel how the overhead feels like. To some people, it may feel like it's just 1.5 extra workload. To others, it may feel like 2 times workload. For others, it may feel like 3-4 times workload. So it also depends on on your own feeling. Oh, and then actually before I jump to the next video, the other thing or the other scenario that the professor didn't really cover in his video is that so far he has been assuming the project will always be like actively developed, following agile practice. Then doing TDD sort of makes sense. And then most of the time it's going to be adding new features rather than stuff like bug fixes or modifying existing behaviors. But sometimes for other projects, especially for projects that may follow like waterfall process, or also more commonly for a project that ended up not as successful, what happens is it has a phase where the application is actively developed, but then later down the line it transits to a more of a operation phase where it's just maintained without major effort putting into it to deliver new features. Then in that case, there's also something you can debate about whether to implement tests, because for the first case where the projects keep being actively developed, adding new features, then most tests would be adding new tests, mostly adding new tests rather than modifying existing tests. Where compared to the second scenario, where it's mostly in a maintenance phase, then for that case, usually it's just modifying existing behaviors without adding new features. And what that means is, without test, if you want to make a modification, you simply modify the code base itself. But with tests, if you are in a maintenance phase, then you actually need to modify the code itself, also modifying the tests. And then sometimes for simple projects, modification can be really straightforward, but with tests it sometimes overcomplicates things, even for some simple changes. And sorry, but last thing I also want to mention, sometimes we may want to implement stuff like A/B testing, where even though we want to add one feature, but we are actually delivering 2 different implementations of a similar set of feature. Then in that case, also if we run A/B tests, then let's say we implement the A/B tests following a TDD, then that means is that we write tests first. We actually write 2 sets of tests first, and then implement the A/B tests. What will for sure happen is one of the implementation will be discarded, right? Because due to the nature of A/B testing, we'll keep one, whichever performs the best, and then discard the other one. Then that's also extra effort, extra overhead wasted, because the nature of A/B testing, So that's also something when you make a decision you can think about, like if I'm going to implement A/B testing, maybe I just write the code base, implement the code base first without tests, and then once we decide whether we're going to use A implementation A or implementation B, we can still add the tests after the fact. Okay, so that's enough of thinking. And we will move forward for the videos, but the remaining videos are mostly just teaching how to use RSpec, and then some other stuff to be aware of while using RSpec or writing unit tests, how to write beautiful tests, and then what makes good tests good, what makes tests bad. So, okay. All right, we will continue to the next video.
So getting started with RSpec. That's weird. This is a famous person, and I think I gave this quote earlier in the course. This famous person said, debugging is twice as hard as writing code. So if you write the code as cleverly as possible, you don't have enough cleverness left over to debug it, basically. Anybody remember who I said this famous person was? Little computer history trivia. This is the designer of the C language. That's Dennis Ritchie. And by the way, a Turing Award winner. Here's another Turing Award winner talking about debugging and testing, who says, testing can never demonstrate the blank of errors in software, only their blank. Anybody care to try to fill in the blanks? Can never, yes, sir. In that order, testing can never demonstrate the absence of errors in software, only their presence or only their existence. That is exactly right. So it's kind of a downer view on testing, to be honest. But I think it's a way of saying that even if you have what you think is 100% test coverage, that's no guarantee that your software will always behave correctly. Nonetheless, high coverage is a good thing to shoot for. And by the way, that was Edgar Dijkstra, many consider the sort of father of the idea of object-oriented programming. If any of you have spent time at any of the Google facilities in the Bay Area, on most of the toilet doors, the stall doors, they have a poster that has this little picture on it, debugging sucks, testing rocks. Google has one of the best cultures of testing, really of any software company that I'm deeply familiar with. And I think I mentioned that they even have, or used to have, I haven't been there in a while, a program called Testing on the Toilet, where inside, like over each urinal and inside each stall door, they have a thing that you can read in about a minute that is some idea or practice that you can take back and make your testing better. So they believe in testing, we believe in testing too, and hopefully by the time you're done with 169, you will as well. So let's now talk about testing at the level of actually writing code. So let's talk about the basics of the anatomy of a test. You sort of have already seen it because Cucumber actually makes this explicit. Every test really has three main components, and I learned that there is now another acronym for it called AAA, which is arrange, act, and assert. Arrange is set up whatever preconditions or assumption the test relies on. So that's like the given part of a Cucumber scenario. Act is do something that stimulates the software. That's usually the when part of the scenarios. And assert is check that something did or did not occur as a result. And that's usually the then steps from Cucumber. So Cucumber happens to make those explicit in its domain language, even though, as we know, given, when, and then are actually just aliases for the same method. But they are sort of the three different parts of a test. And every non-trivial test more or less looks like this. Now, in the very simplest case, if let's say you're doing a unit test for a function that has no side effects, it doesn't have any preconditions, all you're really doing is checking that given the right arguments, it returns the right value. In that case, there isn't really anything to do in the arranging of preconditions. The act is just calling the function, and the assert is making sure that it returned what you thought. But as you'll see, most interesting things you want to test are not that simple, and you need to do something a little bit more sophisticated. So let's take a look at an example, or technically three examples. If we have a hypothetical class and method that does Fibonacci numbers, which you've seen a zillion times in the lower division, I imagine. The very first test here, and by the way, this is an introduction to the domain-specific language that RSpec uses. It's just Ruby code, but it has a function called it, in the same way that Cucumber allows functions called given, when, and then, RSpec has a function called it, which takes a description of a test case and a block of code that actually does that test. So the very simplest one on top, and each one of those blocks is sometimes called a spec because it specifies one behavior, just says it computes the right Fibonacci number. So that's a really easy one. It looks like it's trying to pull out the 5th number of the Fibonacci sequence. If you mentally do the math, that should be 8. And it just says expect the result to equal 8. That's the assertion. So where's the arrange? There isn't really any precondition. What's the act? The act is actually calling this piece of code, which we want to test. What is the assert? It's this. Expect x to equal 8. And what kinds of things can come after 2? There's a point. So RSpec has a whole section of expectations, which are things that you can assert about an expression. I'm going to use some simple ones here, but in the context of doing the subsequent homework, the one that comes after the one that's due next week, and you can also look at the RSpec documentation, but there's a zillion built-in matchers. And there are things like, a lot of them are quite powerful. You can say that, if the thing that's returned is a collection, it should include a certain element. If the thing that's returned is a string, it should match a certain regular expression. There's a bunch of other stuff. Here's another simple case. It rounds up if you give it a non-integer argument. Same basically idea. What about this one? It expects something to b underscore 0. B underscore something is a shorthand, which means call the function 0 question mark on whatever the subject of the expectation is. So this is basically Ruby will turn this into taking whatever is in the expect clause and calling 0 question mark on it, which returns true if the thing has a 0 value, whether it's real or complex or an integer or whatever. And all these things get wrapped up in a block that groups related test cases. So describe doesn't actually do anything, but it groups a bunch of cases together. And as we'll see, it also gives us the ability to set up common preconditions for a group of related cases. So what am I showing here? Kind of, what's the high order bit? It's an example of the simplest kind of test, which is to assert that something is true using expect. Expect expression to meet some criterion. The criteria are listed in this built-in matchers document, but some examples are you can expect x to equal something. You could also say something like expect x not to, like not underscore 2 to equal something, or expect x not to match or not to be 0. There's a pretty strong emphasis on making the test pretty readable. And each one of these blocks tends to be quite short because the goal is to test only one behavior. Right? So the reason you want to do that is that if a test fails, it's going to fail for an extremely narrowly defined reason, and then you can go off and debug it. Here's an example where I'm testing a few different aspects of this Ruby class called book in stock. And focusing on the part down here, the describe getters and setters, basically what I'm trying to do here is I want simple tests that check whether the getters like ISBN and price will actually return those values. I'm also checking that I can set those values through setters. So this is the kind of stuff that you saw with attr_accessor, but I'm showing what it would look like to write a simple test that actually tried to do some of these things. The big difference between this example and the previous RSpec example is that this one requires some setup. It requires some arrange steps. In particular, for each one of the examples, because I'm going to try to call some instance method on an instance of book in stock, I need to have an instance of that object available to call the method on. Now, I could take this line, book equals bookinstock.new. I could insert a copy of that into every one of these examples, because in this case, the setup for all the examples is basically the same. I just need to create a valid copy of an instance of the class so that then I can actually try to call methods on that instance. But because the setup is the same in all the cases, what I've done is I've pulled it out into this block that says before each. So what will happen when this set of test cases is run is that before each one of these is done, the before block will run and set up this instance variable at book, which is then available to that test case. And this will happen every single time. So this is basically like the background steps in a Cucumber scenario where they apply to every scenario in a single file. The before each applies to everything within a single describe block. So this is the reason that describe blocks are useful for grouping together a set of related tests. If those tests share some code for things like setup, you can put all the setup code for all of the examples in that group into one place. So every test still has the same three parts, right? The arrange part, which we've pulled out as a before block that happens before each test. And here's an example of the act part is I'm trying to use the setter for ISBN to set this ISBN field to a new value. Right? Now, these tests are testing something pretty trivial, so I would expect this to work. But this is the actual line of the test where I'm trying to act to stimulate the code to see if it behaves the way I expect. And what's the thing that I expect? That would be the assert part, where I'm now checking that when I call the accessor method for ISBN, I get back the thing that I just saved and not something else. Okay? So the sort of key point of this example is when you have preconditions or arranged conditions that are the same for a whole group of tests, you can put all those tests together into a describe block and then put a before block that actually sets up the preconditions the same way. And by the way, and this will run every single time, right? So there's 4 test cases here, and for the very first one, it will first run the before block and then the test case. Now the second one, it'll run the before block and the test case, and every time a new test case is run, everything that has happened before is forgotten. So you can think of every test case as starting absolutely from a clean slate. The only way that there's any preconditions that are prearranged is either what's in the test case itself or if there's something in a before block. But the effects of doing a before do not last longer than a single example, right? So everything about both frameworks that we're using, RSpec and Cucumber, is designed to help your test be independent by default. So nothing that any test case does is going to sort of persist or bleed over into future test cases. OK, so questions about this example. As always with this, I'm trying to give you the lay of the land overview. So I'm not going to go into a lot of detail on every possible thing you could have done. But I want to make sure that you understand the general template of arrange, act, assert, and that you start getting familiar with the way that you write those kinds of things in RSpec, what expectations look like, and so on.
That's a quick overview of RSpec, and we will go straight into the next video.
Here's a hypothetical method that tries to figure out if today is your birthday or not. And it tries to make use of the exception that if you happen to have been born on February 29th of a leap year, then in most cases, your birthday could be considered as being on March 1st. Otherwise, you'd only have a birthday every 4 years, which is terrible. So what would be some, if somebody just handed you this code and say, OK, your job is test this method, what are some general challenges that come up in trying to test the method? Was that a hand, or was that? Yeah, go for it.
Today is always set the current date.
OK, so one issue is that the very first line of the method retrieves like whatever today's date is. So does that mean that if you test it, the results of the test are going to depend on what the date is? Any other challenges? So that's absolutely true, and we'll deal with that. Other challenges? Yeah.
Birth date might not be like the correct object that we call month and day on.
OK, so what if someone calls this and the thing they pass as birth date is not something that has methods month and day? That's reasonable, but let's assume for the moment that there's some test someplace else that makes sure that when we call birthday today, it gets past the right kind of thing. So it's a legitimate concern, but let's say we can assume that birth date is a legitimate date object. Anything else about this that, if you wanted to simplify testing it, what might you do? So for example, under what conditions can this thing return true? Well, one possibility is just simple match. The other possibility is sort of this corner case. So probably if your job was to test this, you would think that you at least need to write one test to check each of these possible code paths, right? And as we're going to see much more when we talk about refactoring, usually when I see something like that, if I see a function that I'm trying to test, and what I'm seeing is, there's sort of 2 or 3 quite distinct things that could happen here, And my test somehow needs to make sure that I hit each of those distinct things. To me, that says this should have been 2 or 3 distinct functions. Right? So I can imagine having some helper functions. One of them just sort of handles the straightforward case. One of them handles I guess what I'll call the edge case. And I could test those functions separately. And then all I really have to do is test the shell of the function, which calls the helpers. So we'll talk more about that idea of decomposing a more complex function into simple ones. But for now, let's deal with the one that came up first, which is how do you sort of break the dependence on something like this on a day of the week? Or in general, how do you test code in isolation if it has dependencies that would affect the test? And in the example that I gave just now, the dependency is a little bit weird because it's a dependency on what appears to be what the date is. But there are dependencies that are much more mundane and that you still have to deal with. For example, if you're testing a function that calls some other function, you don't want the results of your test to somehow depend on whether the function that it's calling is broken or not. Right? In some sense, you'd like to be able to make certain assumptions about the helpers. And that's what we're going to talk about today and Thursday. Seams. Remember seams. Because seams is how we do the dependency breaking that allows us to get a little further in this test. What is a seam? A seam is a place where you can change something about the behavior of your app without changing the source code of your app. This is from the best book ever on working with legacy code, by the way. And I'll show you an example of how we're going to, and by the way, it's called a seam because you can imagine, like in clothing, you can imagine like temporarily unstitching something at the seam, sticking something in there, and then maybe stitching it back together later. I guess that's how it got its name. But the idea is that there are certain places where you can do things that change the behavior of the app without changing the source code of the app. And I'm about to show one of those and how it works. The reason that seams are important for testing is exactly that they allow you to isolate the behavior of code that is not part of the test, but is dependent on by the thing that you are trying to test. So we're going to show a seam that is based on the same use of expect. But basically, it's a seam that says, I'm going to call some piece of code in my app. What I expect to happen is that piece of code is going to call some other function to do some work. Now, that other function that does that other work, that's not what this test is about. This test is to make sure that when the user submits the form, the right thing happens and that other function actually does get called. So the only expectation I care about for the controller method is, will the controller method call that method in the model? I am not testing that the method in the model does the right thing. We could have a separate test for that we create later. But what's the controller's job? The controller's job is receive the form and make sure that it passes the right thing to that downstream method. That's what the test is about. And the reason that this is kind of cool is because we haven't written the class method yet. The method that's going to do the work, we're going to pretend that it exists. That's why I sort of call this approach the code you wish you had. We wish we had a method that was already defined in the movie class that actually did this work. We do not have any such method. But amazingly, that does not prevent us from writing a test for this controller. Because all we're checking is, if this method existed, does the controller do the right thing in terms of calling it? Okay, that's where we're going. So this is a really, really useful concept. That kind of an expectation is called a stub, or a double, or a mock. The terminology varies, but we'll hear all three. And just like with preconditions and anything else, we're going to set this up for a specific test case. But once that test case has run, anything we do with this seam is going to go away. Okay, so that's kind of the preview of what we're about to do. So we've established that calling the doing the actual search in TMDB is the model's job. We're going to have a class method that does it. And let's assume that that class method, if it existed, had this useful name, find in TMDB. So what we're going to do is fake the ability to call the code we wish we had. So here's the strategy. We're going to simulate posting that search form from the controller. This is something you've already, this is what Cucumber does when you say, when I press a button, it just submits the form. Then in our test, we're going to check that the controller action that receives that form tries to call this method, and that it does so with the data that came from the form. OK, so the test is actually doing something useful, because you can imagine, let's say that the way you wrote your view, the field that the user fills in with what to search for is called movie title. but then when you're writing your controller, you accidentally think that it's called title, and you look for the wrong thing in params, right? That's an example of the kind of thing that could go wrong because the code is touching both the view and the controller. So we're going to check that the controller action not only tries to call this method, but that when it tries to call it, the thing it passes to the method is the right thing, that it's actually the same data that the user filled in on the form. Of course, this test will fail, because right now we don't have any code in our controller whatsoever. And then we can easily fix the controller action to make it pass. Okay, so, but the key thing here is we're isolating what the controller's job is, right? We're not making any claim that this method exists or works or anything. We're just saying that if it existed and it worked, we want to make sure that it gets called at the right time and gets called with the right argument. Okay, that's where we're going. So here's how we do it. And there's actually not a whole lot going on here that you haven't already seen. So line by line, describe, that's just used to group together a set of related examples. Here's our first example. It calls the model method that performs the search. And here's the thing that's new. Expect movie, and remember movie is a class, and we said that the method that we wish we had would be a class method in the movie class. So expect the movie class to receive a call to a method called find in TMDB with a particular string passed as an argument. Why are we saying this string is passed as an argument? Well, let's take a look at the next line, and then I'll explain why these lines are flipped in the order they are. Here's an RSpec construct that says, do a post to this action in the controller and pass this exact thing as the params hash, right? So this is the line that actually does the acting. It says, generate a form post to this specific controller action. So don't even, it bypasses routing entirely. We're telling it the exact method in the controller to call, and make the params hash look just like this. Because the idea is that if the user had actually filled out a form and the name of the field was search terms, and the user typed the word hardware, then what we would want the controller method to eventually do is to pass that value down to find in TMDB. So let me pause for a moment so you can sort of ingest a little bit of this. And let me ask the question. This expectation, this is an assertion, right? The expectation is I am checking whether a particular thing is true. In this case, whether this call happens and whether it gets this argument. So my question is, why does the expectation look like it's coming before the action? Usually it's supposed to be arrange, assert, or sorry, arrange, then act, then assert. But here, the assertion comes before the act. Why is it necessary to do it this way? Anybody want to give it a try?
Well, since it's like trying to simulate a function, you won't actually want to do the thing the function's supposed to do until you're sure that function actually got called.
I think try that one more time. I think you're on the right track.
Like, because like you need to call the function and then get the results of calling that function, and you wouldn't want the results to come if it didn't actually call the function.
OK, so let me paraphrase what I think you said. And I'm going to use the term that you will probably hear used in the testing literature. In general, if I want to make sure that some function gets called with a certain argument, what I really want to do is I want to spy on that function. So in some sense, I want to be notified. If someone tries to call that function, I want to hear about it. Right? That's kind of what I'm saying here. So Ruby provides a way to do this. What happens when you set up this toReceive is that it actually sets up a fake method in the movie class. It temporarily defines a method with this name, but the method doesn't actually do anything except wait to see if it gets called. Okay, so it sets that up. Now the rest of the code inside the test case runs. And by the end of the test case, the testing framework can query this fake method that it set up and ask, hey, did you get called or didn't you? And if you did get called, was this the argument that you received? So in some sense, because we know we want to spy on the method, we have to make that statement in advance. Otherwise, if we didn't say this first, then the method would get called, but there's no way to ask, was it retroactively, did that method get called or not? It's too late. Whatever happened, happened. Right? What we need to do is essentially set up a watcher so that if the method gets called, we can immediately note that fact. So that's why it looks like, in fact, it looks like the assertion comes before the act. But this part isn't really checking the assertion. It's just setting up a condition saying, OK, by the end of the test case, see that this happened. If it hasn't happened by the end of the test case, then that's an error. Then the expectation has not been met. Does that make sense? It's a little bit hard to get your head around the first time you see it, right? But that's why the assertion in this case has to come before the action is taken. Because in some, you can almost think of this as setting up a precondition that we're going to spy on that function. Later, when we talk about JavaScript and the way that you do some of these same things in Jasmine, which is the JavaScript testing framework, they actually have a term called a spy. And what you do is you create a spy, and you alias the spy to the thing that you want to see called. Now, keep in mind that the only thing this controller method is going to be responsible for doing is calling find in TMDB. This find in TMDB method doesn't actually do anything, right? The only thing it does in this test case is it verifies that it got called or not. But there's no functionality in there. In fact, I'll go you one better. And even if this method did exist, right? So now imagine that it's 2 weeks later, and some other developer on the team has actually coded the real find in TMDB method in the movie class. This test case is still going to stub it out. So the way that this test is going to work, even if there's a real method with this name in our app, this test case is not going to call it. It will still set up a fake version of the method and verify that the fake version of the method got called in a certain way. It will not even touch the real version, even if it's there. So my question, and it's not a clicker question, it's just a let's put on your testing hat, why is that a reasonable thing to do? Even because you might think that once this method has actually been coded in the app, that we sort of don't need this anymore. Why would I advise keeping it in despite that? Thinking about isolation, what would be an argument for keeping this test the way it is, even after the real find in TMDB method has been implemented and we know it's working and stuff like that? Why do I still probably want to keep this test case just like this, calling a fake method? Give it a try.
Well, this test is for the controller, right?
This test is for the controller.
You don't want to have the controller test be dependent on that other thing.
That's right. It's test independence, right? The only thing I want to test here is if the controller is doing the right thing and trying to call the right helper. I don't want to make that test somehow dependent on the helper itself. What if the helper breaks at some point? What if the helper takes a long time to run? But just in general, anything I can do to isolate my code that I want to test from all the other things it depends on. Okay, so that's why it's important that when you do something like this, right? What have I done here? I have set up a seam. I've basically said, at the place where find in TMDB exists in my app, if it exists at all, open up that seam and stick an observer in there so that for the purposes of the test, the real find in TMDB will not get called. In fact, I don't even care if it exists. I just want to know that something with that name got called with those arguments. And that's it. End of story. Right? And of course, in real life, this test would never work as part of a full workflow. Right? In a Cucumber scenario, you couldn't do this. You need to call the real find in TMDB because the scenario is going to do a workflow that has many steps. But in a small test like this, where you're checking a limited amount of stuff, you stub everything, pretty much. A very related concept is a double. And double in this context means think in terms of movies like a stunt double, someone who is a stand-in to do a dangerous thing when the actual actor is not supposed to be doing that thing. So going back to this controller method, this hypothetical controller method that we're writing a test for, the first thing we said is the controller method should call the find in TMDB function to get some results. And the second thing we said is once it has those results, it should make them available so that some view can potentially show the results to you. So again, you're going to see a lot of RSpec and RSpec Rails documentation, but I will just tell you for the moment so that we can think about, sort of focus on strategy here. There's a method provided for us in the testing framework called assigns that basically lets us ask, did a particular controller instance variable get set, and what is its value? So remember that the controller instance variables are the ones that become available in the view so that you can incorporate them into the view. So basically what we want to do is not just check if the controller action is calling find in TMDB, but it's setting some variable that the view will actually be able to get to. And of course, the version of the code that I said before, look, this is just enough code to pass the test. Well, that's true, but it's not going to pass a test that looks for assigning the result, because we're not assigning this result to anything. We're just sort of calling this method, and we're throwing the result away. So the question is, in this case, back to the idea of, OK, what's the code we wish we had? Well, the code we wish we had might be something like this. There, that's better. Something like this. Ignore that intermediate stage. where we're not just calling this method or a seam for the method, but we're actually assigning the result to something. Because in real life, that's what we'd want to do. So we are now in the position of needing to write a test that actually checks if this variable is getting assigned to. By the way, that's different from checking if find in TMDB got called, right? It's possible that the return value from find in TMDB might go through some other intermediate processing and then ultimately get assigned to some instance variable. So our test is really just concerned about does it get assigned to some instance variable in some reasonable way. And a way that we can check that is another type of seam the testing framework provides. Depending on who you talk to, some people call it a double. Some people call it a mock. There's a particular method that we're going to use to create it called instance double, which, given a class name, gives you a stunt double instance of that class. Now, the stunt double is actually pretty stupid. It can't do very much. In particular, it doesn't know anything that the real class knows. Kind of the same way that the expectation creates a fake version of the find in TMDB function. That fake function doesn't do anything, but it exists sort of as a placeholder just for answering the question, did I get called? This is the same idea. It's going to create an instance of a class that looks just like. If you ask it, are you an instance of movie? It'll say yes. But it can't do anything that a movie can do. It doesn't know about the accessors. It doesn't really know about any of the behaviors. We have to endow it with the specific behaviors needed for our test. So like any other kind of seam, the goal is give you just enough functionality to test some specific behavior. So in this case, what would that mean? Well, we could set up an instance double of the movie class. And we're going to stub a few of its methods. To stub a method is kind of what we did in the test. It's to create a fake version of that method that exists and can be called, but doesn't really do anything necessarily. So to stub it, we're going to say allow this stunt double to receive, in other words, to have the method title called on it. And if it's ever called on it, it'll return some canned string. OK? So we're basically creating a fake object. And when you call a method on that object, we're controlling the return value. And similar to the other seam that we saw, you get the method name. You can specify a canned return value. There's also a syntactic shortcut where at the time that you create the instance double, you can provide some key value pairs saying, if this method is called, return that canned result. Right? So again, it's a really, really, really not very smart object that is going to be used just when you need a stand-in with very limited abilities. Right? So what are the abilities that we need in this case? Well, if we're just passing it to another method, if we know how the stunt double object is going to be used, we'll just define simple behaviors for those particular methods and nothing else. So what is this going to look like? Going back to our test case, within our test case, we're going to create a list of fake results. If the find in TMDB method really existed, what would it probably return? Well, it would probably return some collection of movie objects that are the matches it found in the database. So we're going to create an array of 2 of those things. Each one is an instance double. These instance doubles actually don't do anything. All they do is sit there and look like movies. If you ask them to do anything that a movie does, like tell you their rating or something like that, you just get an error because they're not real objects. They just look like them. Nonetheless, we can create a set of those. And now we can say allow the movie class to receive find in TMDB. That part we've already seen. But we can augment it with and return something. So this says, if the movie class receives a call to this method, here is what to return as the canned result of that method call. So I kind of think of this as those machines that used to be popular in gyms, but I think they're not anymore. They used to call them Nautilus, but it's the one where you can isolate just this muscle of your forearm by doing it enough times. Right? That's kind of what these tests do. You're holding fixed everything around your test code and providing just enough behavior with these stunt doubles to test the one thing you want to test. And then, after you've done the post, the controller action has been called. Now is the assertion part of the test. We're expecting that the instance variable movies got assigned, so the controller set a value for that variable, and that value equals the thing that ultimately got passed to find in TMDB. Now, it looks like for a really simple controller method, this is overkill. And I needed to choose a simple example just to show you how this machinery works. But the general idea is always the same. Anytime you're testing a function and that function has an external dependency on something, if the dependency is on an external method, even if it's in the same class, you can say allow to receive, and you can can the results of what that method is going to come back with. So this is a way to isolate your testing very cleanly, even within the same class. How come here, instead of saying expect movie to receive, I'm saying allow movie to receive? A subtle distinction, but an important one. Anybody want to take a look, take a guess, take a crack, take a... What's the difference, just in terms of what the word is saying? And I know you've not seen the syntax and stuff, but in terms of expect versus allow, what's kind of the difference between those two statements? Expect movie to receive a call, allow movie to receive a call. Go for it.
Maybe with respect, with expect, then it's like false if it doesn't happen, whereas with allow, then it's...
Exactly right. So if I say expect movie to receive some function call, then it is an error if the test finishes and it hasn't received that call. If I say allow movie to receive a function call, what I'm actually saying is whether movie receives that function call is not the thing that I'm testing. And in fact, it might receive that function call 0, 1, or some other number of times. What I really care about in this test is the last line. Expect is the only thing that makes the test really fail or not fail. So if at the end of the day, the movie's instance variable of the controller has been correctly assigned to fake results, this test doesn't care if that happened because movie received this call or if it happened some other way, right? This particular test is just checking whether it got assigned correctly. So you can say expect to receive or allow to receive, but that's the difference. If you say expect to receive, you're saying this test should fail if it doesn't happen. Allow to receive means it may or may not happen, and whether it happens is actually not the point of this test. But if it happens, here is what to do. So the question was, is there any way for movies to be assigned to fake results other than this actually happening? In this simple example, probably not. But there are examples where basically you're setting up some. So this is, if you remember the pattern of arrange, act, and then assert, this is essentially the arrange part, right? This is setting up a precondition or setting up the world such that if a certain method gets called, it can return a canned result. In real life, there are going to be cases where, in some sense, the distance between this setup and the expectation is much larger than in this really simple example. So in this really simple example, I'm hard-pressed to think of a way that the expect could be true without movie having been called. But in real life, it happens all the time, right? And really, when you use allow, what you're saying is, I prefer to be ignorant of the implementation. I'm just thinking that this thing could be called, but it's not part of the test. But you're right. In this very simple example, it seems a little contrived. I agree. By the time we get to this line of code, the expect line, the controller method has finished executing, and presumably that means that all the state associated with the controller has been incinerated. So how is it that this assigns method is basically able to check the instance variable? TLDR, the test framework essentially hooks into the controller, and before the controller method is allowed to relinquish control, there's a way you can ask an instance of a Ruby class, tell me all of your instance variables and their values. So it uses introspection. Before the controller instance is incinerated, it asks the instance to list all of its instance variables, and it just basically has a big hash of them. And then it just looks up in the hash whether this one is set or not. What is the scope of this allow? The scope of allow, expect, doubles, anything you do in a test is just between the it and the end. So once this test case finishes, everything we've done in here to set up seams is blown away. And any other test case that wants to do the same thing has to either repeat this line, or you can pull it out into a before block like I showed last time. You can have a before block that applies to several different test cases. Good questions, though. Each spec, which is one way to talk about a particular test in RSpec because it specifies a behavior, should test just one thing. And ideally, you use as many seams as necessary to isolate that behavior and control all the ways that it can go wrong. What kind of expectation? So what is the thing that you're checking? What is the one thing you're checking? And in an ideal RSpec test, there will be exactly one expect, right? Because if there's more than one, then you're maybe testing more than one behavior. And if there is 0 expects, then the test is not asserting anything, so there's sort of no way for it to fail. Make sure the test fails for the right reason. So what would be a wrong reason? Well, syntax error, that's a wrong reason. Or you're trying to call a controller method that doesn't even exist. That would be a wrong reason. Once it fails for the right reason, now you're in good shape. Because all you have to do is add code until the test passes. And believe it or not, that's actually the easier part of the job. Structuring your code so that you can write tests that test one behavior each is actually the more challenging part. Okay, so that's basically it. So where are we with RSpec? We've learned about using expect or allow, and you can either say expect a class to receive a method call or an instance of an object, right? I can create a movie object and say, expect this object to be asked its title. And when it does, return a certain value. I can make a double, which is really stupid, but then I can tell the double to implement specific return values for methods that it's called. And in the RSpec documentation, there's a whole bunch of other expects that you can do. You can expect an object to match a regular expression. You can expect a collection to include or not include a certain element, and so forth. And there's a number of Rails-specific extensions like assigns to see whether the controller assigned a certain variable or not. There's also response, which models the response object. So you can ask things like, if I call the controller method, it should do a redirect at the end. Right? You can ask the response whether the response is a redirect or whether it's just a normal payload being sent back to the client, things like that. Okay? So again, that's the idea of what we're, oh, and we saw and return, which allows you to control the return value, but is not mandatory. If you don't say what return value you want, then the function will just return, the fake function will return nil. All right? And these are the ones that we used in kind of our most recent scenario.
All right. We'll go straight to Xvideo.
Imagine that you're doing a test where, like in our hypothetical example we were doing, what you're testing is that you're eventually going to call this other service, TMDB, to ask for matches to a list of movies. Right? Now, in the hypothetical test that we were working on, we were only concerned about, does the controller do the right thing? And therefore, we were stubbing out the method that eventually is going to make the call to the real TMDB external service. But if you were doing a cucumber scenario for this, the question is, in that cucumber scenario, do you actually want to call the real external TMDB? Because now you're introducing essentially a dependence on the rest of the internet into your test. Not so good for test independence, right? So if you're going to say, well, OK, what if we can get all the way to where TMDB would be called, but we'll stop there. At that point, we'll put a method stub in. Just like we stub the findInTMDB method itself, we can find some place in the app right before it hits the internet, and we'll do the stubbing there instead. And that's basically the approach that you can take. What we already saw is we stub out the world, right? The findInTMDB method doesn't even get called. That's what we did in the controller test. Sometimes these external services have a gem or a library that wraps the API to the service. So we used to have a Ruby TMDB gem that did this. But to give a real life example, think of something like Stripe, which is a payment processing API that I'm sure you've all heard of. If you look at Stripe's website, the documentation for the Stripe API is it's just a RESTful API. It uses HTTP, GET and POST, all the things you've already learned about. But if you want to use Stripe from a higher level language and framework, like Ruby or Python or JavaScript, they have really nice libraries that shield you from having to deal with actually manipulating the low-level Stripe API components. That you can say something like, Stripe, create a charge for this credit card for this amount of money. And you don't have to worry about what the HTTP route looks like or anything like that. There's a library that deals with all that for you. In those cases, you can stub the library. So here, I have a hypothetical library called TMDB movie that shields you from the low-level aspects of the TMDB API. I can say, when my app tries to call that library, stub that call. And instead, return some canned values, simulating what the TMDB API would return if I really called it. I can probably be a little more compulsive and say, well, even if there's a library, at some point, that library has to use Ruby's functionality for actually using the internet. So I could stub at the level of HTTP. And at this point, basically, what am I testing? Well, if this library is a third-party library, maybe not so useful. But if this is my library, maybe what I want to test is when I tell the library to go out and do a certain API call, I want to make sure that the library is producing the correct API call, that it's producing the right URI, the params look correct, the HTTP method used is correct. So in those cases, I can actually stub the Ruby library and say, OK, right before you make the HTTP request, stub there. And allow me to see what is the exact thing that would be sent over HTTP to the remote service. And in fact, for some of you, if your projects involve interacting with an external service, there's a Ruby gem called Fake Web that does exactly this. Basically, you can use this gem to return a canned value that looks just like what a real API would return, like the raw JSON format and everything. And then you can test if your app is parsing that properly, should that be of importance to you. If you're using something like fake web, and then finally the last version of this is even if you've done all those tests, you probably also want a staging environment, which is where your app is running in an environment that looks just like production, but it's not the one with the real customer's data. In the staging environment, you might actually want to run real live tests that really go out and hit the remote service. Why do you need to do that? Well, because in real life, when you make an API call to a remote service, there are ways that it can fail that are not trivial to reproduce in a control testing environment. For example, if the internet is really, really slow that day and your call times out, you could find a way to simulate that locally, but it's kind of a pain in the butt. Or if the remote server actually is overloaded and it sends you back an error. Again, you could find ways to simulate that, but as a sanity check, you might want to have a real test in your staging environment that interacts with the real remote service. Most remote services that have a lot of clients, like for example Stripe, actually provide a separate version of their service. Sometimes they'll call it a sandbox or a staging service, which has an API that behaves just like the real service in every way, but for example, in Stripe's case, no money changes hands. So instead they say, if you want to simulate a card being declined, for example, use this specific credit card number when you do a post. If you want to simulate a transaction being declined because it's too high, use this specific card number to simulate that. You run those against the staging server, and the mechanics are identical to the real thing, but the effects are not the same, obviously. Okay, so all of which is to say, testing is about isolating behaviors in your app, the things that you're trying to test, from behaviors that are incidental to it, but you need to somehow have those behaviors in play in order for the test to work. And the ultimate example of this is when your app up here depends on a remote service. And where do you do that stubbing? The answer is it depends on what's the thing you're trying to test. So the rule of thumb, I guess, my guideline is I stub as close as I can to the top of the stack for unit tests, right? Because I'm trying to isolate as much as possible. I stub closer to the bottom of the stack for integration testing because I want it to be as realistic as possible. So if I'm really going to call the TMDB database, I'd like to get all the way up to the point right before I call it and make sure that my call looks sane. And that is all stuff that I can do stubbing up here. Maybe in my staging environment, I'll actually have an additional test that calls out to the staging server for TMDB. But in general, stub a lot up here and stub a lot less down here. Same thing. OK, so questions about I think this has sort of been a 2-day whirlwind overview of the main concepts of testing, which is where and how do you create stand-in fake behaviors, whether it's double objects or stubbed method calls, so that your test can just focus on the thing you want, and you can isolate the test from things around it, right? And the higher up you are towards unit tests, the more you're going to be doing that isolation. The further down you are towards integration tests, the less you're going to do it because you want those tests to be realistic. You're testing how the whole thing works together.
All right. So we only have about 30 minutes left in the day. So before we, so we will move the remaining videos for Thursday. And before we go, I do want to again demonstrate how to set up the hands-on practices, and then if we still have some extra time left, then we'll set up a Google Meet for you to do practice and ask questions if you have. For this week, week 7, the homework again. The basic option is to add a summary on chapter 8, which should be about TDD. So if you want to go with the basic option for homework, read the chapter, read the textbook chapter 8 and write a summary about that. For bonus option or the hands-on option, you can find this repository on GitHub, which is titled TDD with RSpect. So now I'll show you how to set up this code. Give a moment to at the terminal or the command line to the screen. Right, hopefully you can see my terminal. So again, first step is to fork it. Then call that to our local environment. So this practice it talks about setting up Travis CI, which is a continuous integration tool. So I will skip this part, but you can always do that on your own. And the real setup is from here, part 0, call that repo, then like other practices, bundle install and install the dependencies and all this stuff. But pretty much you can just follow the documentation, and I will show it here. So bring over here to if you see this warning saying that you need to install Ruby 2.7, you can just copy the command from there and install it. Wait for it to finish installing. Okay. CD back into the directory, and then it should automatically switch the version to the specified one. Excuse me. Then copy the command. I'll install it to install the dependencies. Oops, forgot to install the bundler. It's over there. Right, so basically they're saying we need to downgrade the Ruby gems down to like 2 point something. So let's see, what's our correct version? You can find your current Ruby gem version by typing gem version. And then this has 3 point something, which is indeed incompatible with the desired gem. So for something like that, Google is your friend. Just Google that. Downgrade Ruby gems to so we got this command, and then we need to figure out what's the latest version of gems 2. And typically you can find that, go to the corresponding GitHub repo, find the tags, find the latest version of a specific major release. So if you come here, looks like the latest one is 2.7.0. So we'll go ahead and do that. So 11. It. Let's verify we now have the right version. Yes, we have the right version. And go back to this command. And what's that? Okay, that's weird. Anyway, looks like something is not quite right as I tested last time. Anyway, I will spend some more time and figure that out. So we'll move this one to next lecture. So I'll show the demo again once I figure that out. It's probably gonna be at the beginning of the next lecture on Thursday. So now then, for the time being, but anyway, the homework is basically go on this repo, run the setup, and follow the instructions, and do whatever needed. It will ask you to follow the cucumber scenario and then implement the RSpec tests. And I believe it also asks you to write the actual code to implement the specified feature. Alright, so we'll just pause on that. Also, if you want to get yourself started, you can also just follow whatever commands is in the documentation, and if you run into the same arrow as what I see right now, you could also just Google and try to figure it out. But otherwise, if you couldn't, we'll revisit this one on Thursday. Okay, then looks like we've got some extra time to finish a few more videos. So let me get rid of the terminal. And we will continue. So yeah, we will watch another video, and I think we should have enough time for that.
Fixtures and factories, still in the world of testing. And here's the scenario we're going to look at next. So far, we've said you want to isolate the test from things it depends on. That's always true. And one way to do that is to create either fake methods, method stubs, or fake stunt double objects, in both cases, whose behavior we control, and to use those in the test instead of the real thing. But what if there are cases where having the real thing would actually be better in some limited way? For example, suppose we want to have a test that does something like the following. We're going to start out by creating a stunt double of a movie object. And we know that we're going to end up passing that stunt double to something that is going to expect to ask the movie what its title is. OK, well, no big deal. We could just say allow fake movie to receive the title method. And if it does, return something. Fair enough. But if that same method that we're going to call is also going to ask it for its rating, OK, well, now we have to set up another stub and say, OK, also stub the rating method. And if that gets called, return PG. And if there's also a third method that might get called name with rating, we have to stub that too. And by the time you're done, basically you've re-implemented everything a movie actually does if you had a real movie. So what do you do in a case like this to keep your test separate from the real thing, but when you actually want an object that has all of the behaviors, not just a stunt double that can do one or two things, but substantially everything? So there's kind of two places you can get a real object. One of them, which you should not use, but I'm going to explain how it works so that when you see it, you're like, you shouldn't use it, is called a fixture. And in a SAS application, basically this means because the application relies on storing all the models in a database, we can put some hardwired objects into that database before the tests run. The test can expect to find the objects there, and those are real objects whose properties we know. So they can use the objects in a predictable way. They know what the name of the movie is because it's always the same one preloaded in the same place in the database every single time. You shouldn't do this for reasons I'll soon explain. The other way is what's called a factory. And those of you who have ever read about design patterns or something, not to be confused with anything having to do with a factory pattern in software. This is a different use of the word factory. A factory is a way to create the objects you need in a way that says, look, create me a movie. I actually don't care what the attributes are, but they need to be actual attributes. They need to exist because somebody might ask for them. Or maybe I want to selectively override certain attributes. But for the most part, I just want an object that behaves in every respect like a movie, but I don't care what the details are. So let's look at each one of these. By the way you can spot something like this is if you see a test, here's an example that I'm going to give that if you wanted to search for a movie by its director or by the awards it received. So if I had an expectation like movie.award.type, well, this is pretty awkward because if M is a stunt double for a movie, not only do I, and similarly I can say, the name of the director equals, the problem is that now I have to actually double all of the things, right? I need a dummy for the award and the director, and I need to say, on the double movie, return those things. Like, this is a mess, right? This is more code than you should have to read, and it doesn't test anything interesting. Some people call this a mock train wreck, mock being another word for the stunt double object that stands in for the movie. So, when you see this kind of like, boy, I have to call this chain of methods, so I have to basically mock everything along the line, that's a sign that something is wrong with your design. But setting that aside, fixtures and factories, the two ways to get a real object. First way is very simple. You can have a YML file in spec fixtures, and in that file you can have a handful of movies that, where you have basically predefined what the attributes will be. And then any test that wants to take advantage of that can just say, I'm going to grab the movie whose label in this file is milk movie, and now I know exactly what the attributes of that movie are. So I can write my test code around the assumption of what these things are. Before I deprecate this, can anybody, or would anybody like to guess why I'm about to deprecate this and say, in general, this is not how you should do it if you need a real movie, and I'm going to show you a better way? What is wrong with doing it this way? Or what is potentially a pitfall of doing it this way? What good property of testing am I breaking?
Well, if you change something about the movie, you have to go back.
Yeah, so one problem is if I change what's in here, all of a sudden I might have a bunch of tests gratuitously failing because they rely on these specific values. And in fact, there's more subtle things, right? Like suppose I add a third one in here because I have some other test that wants to use one. But somewhere I have a test that makes assumptions about the number of movies in the database. All of a sudden, that information has now leaked out of my fixtures. So in general, you shouldn't use this to create objects used in your tests. You can use it for things like configuration data, data that is not changed very often and is required for the app to work properly. Example, the time zone in which the user wants to run the app. The app needs that information to function. It probably doesn't matter what value you pick, but the app just won't run, and therefore you can't really have any tests unless you have a value for that. So those are the kinds of things that you might use fixtures for, right? Really static data that is not part of the logic manipulated by the models. If you use fixtures, just like everything else, the database is incinerated and reloaded at the beginning of every test. So you get a degree of independence. But again, if you have tests that depend on specific things about the fixtures, you may be endangering that. So my recommendation was use it for truly static or very, very slowly changing data that the app needs, but that is not really central to any particular test. It's sort of needed for anything at all to happen in the app. And the main reason is you might end up introducing one or more dependencies on the fixture data, and now you've broken tests being independent from each other. So what is a better way to do this? The better way to do this is a factory. And a factory is basically a place where you can provide instructions to say, to create a movie, here's a basic sort of blueprint for doing it. Don't bother me about the details. So there's, compared to fixtures, your tests are a lot more independent because each test only sets up the specific objects that it needs. There's no possibility of random other things being in the database that the test did not expect, and that therefore that might somehow interfere with the test. The one thing to be careful of is that when we talk about associations next week and the ways that models can be related to each other, you might have to set up sort of a complex relationship of things in order for a test to happen. So for example, if I'm working on a social media app and there's a notion of me being part of a graph of friends and I want to test something about the connectivity of that graph, I sort of have to create a little entire graph in order for any test to work. It is still probably in most cases better to factory that than to fixture it. But in many cases, when you find that a test is hard to set up, what it's really telling you is that your code is too tightly coupled. That the fact that you can't test these behaviors sort of in a small space might indicate a design problem. So setting the design problems aside for now, what is it like to use factories instead of fixtures? Well, there's a gem for it. It used to be called Factory Girl. It was renamed Factory Bot a couple of years ago. I am OK with either one. I think Factory Girl refers to the name of a movie that is before my time or something. But basically, here's the way it works. You have a separate set of files where you define your factories. And here's an example factory. Again, don't worry about the syntax. My goal is to help you understand how factories work and how they are used. Here's an example factory for creating movie type objects, right? Objects of the movie class. Basically, it says when you need a movie, I'm going to give it the title, a fake title. I'm going to give it this rating, and I'm going to say that it was released 10 years ago relative to whenever the test runs. That may or may not be a good choice for your application, But basically, this is a way of saying, create me a movie when I don't care too much about the details. In my test, when I need a movie object that has all the behaviors that a movie has, I can say build to create an object in memory but not put it into the database. Or instead of build, I can say create. That actually creates the object and sticks it in the database so that now I can use active record find on it if that's what I want to do. I can selectively, as I did here, I can selectively override certain attributes of the object. So here I'm saying, I want a movie, and I definitely want the title to be milk, but I don't care about the other stuff. So this is pretty convenient, because the thing you're going to get back is a real flesh and blood movie object. It's a member of the movie class. It responds to everything a movie responds to. It even lives in the database if you said create rather than build. But it's temporary. After this test is over, it gets blown away. And in the meantime, you can do everything to it that you would do to a regular movie object, right? And again, you'll find that this is useful when, if you have a test that isn't really about movies, it's about something else, but it needs to consume a movie object just to get the code running. That's a case where you say, just give me a movie. Any movie will do. Make one for me on the fly. And that's when factories really help you out. Okay, so they're quite simple to set up. Now, you might say, well, Active Record has a way of just doing things like new and create, right? The way that we would have code in our app to create new versions of that model. Why can't we just use that? And essentially, that's what FactoryBot does. It just pulls the code out of the main line of your testing. Rather than having your test have to worry about the movie attributes it doesn't care about, we've hidden that stuff somewhere else. And as you'll see when we talk about associations starting next week, in the event that movies have connections to other things, like reviews or moviegoers who saw it or tickets or anything like that, FactoryBot provides a really nice way to set up those relationships transparently. So your test code doesn't really get polluted with the details of building a movie. It's enough for it basically to say, I want a movie, and I want this to be its title. I don't care about anything else, right? So it lets the test code itself be pretty narrowly focused.
All right, that's about it for today's lecture. So again, you can find your homeworks here. And then for the hands-on one, I'll test it again and then figure out what went wrong. But feel free to go ahead and try yourself. It might work out of the box for you. And oh yeah, so basically for the videos we've watched today, I introduced the idea of TDD, although we've had a discussion about the pros and cons of TDD, and then we pretty much had a walk through one of the tools for Ruby, which that is RSpec, and then for other languages you can also find similar tools like what is mentioned in the video. For JavaScript, there are Jasmine. There are actually a couple more. I don't remember exactly. JUnit. There's something like that. JavaScript actually has quite a few different options. Like PHP has PHP units. And pretty much every language should have at least one unit testing tool. And then there are some other tools that helps you to write better unit tests, like what we mentioned just now. Something like Fixtures, something like Factory. It basically helps you to make each test as independently as possible, as well as help you to keep the test clean and dry. Yeah. So I think we have a few more stuff to cover, but we'll do that on Thursday, and then we will. Actually, we'll just talk about the other stuff on Thursday. Right, so that's it for today. I'll see you guys in 2 days. Bye.